everyone, and welcome to the MathDBase.com Anacast series. I'm your host, John Casiedu. In this installment in the Algebra series, I will discuss Algebraic Techniques, Part 2, Evaluating Expressions. A mathematical expression is a string of numbers and/or variables called terms, connected by operation symbols according to a specific syntax. These are purely numerical mathematical expressions. We also call them arithmetic expressions because they contain only numbers. These are algebraic expressions because they contain the unknown value x. A mathematical expression can have a single term, which could be a variable, a letter, or a symbol representing an unknown or unspecified number, or an expression can be a single number. Expressions can be relatively simple or more complex. An algebraic expression will have a numerical value whenever each variable in the expression is replaced by a specific number. If x equals 9 and y equals 4, then the expression x minus y has the value 9 minus 4, or 5. And the expression x over y has the value 9 over 4, or 2 1/4. The general algebraic expressions x minus y and x over y have specific numerical values whenever x and y are replaced by numbers. The process of finding the specific value of the expression after assigning specific values to the variables in the expression is called evaluating the expression. To do that, replace each variable with the number that is given. Assigning specific values to the variables in an expression can be phrased in different ways. A problem might say, replace x by 3 and y by 2, or it might say, substitute 3 for x and 2 for y. A problem might say, find the value of if x equals something and y equals something, as we saw earlier. All of these ways of saying it mean the same thing. The value of x is going to be a number, and the value of y is going to be another number, though possibly the same number. Let's look at some examples. Evaluate this expression when b equals -5, x equals 6, y equals 1/2, and z equals -8. Replacing the letters in the expression with the numerical values, we have -5 times 6 plus -8 divided by half, minus 1. -5 times 6 is -30, and 8 divided by half is equal to 8 times 2 over 1, using the fact that dividing a number by a fraction is equal to multiplying that number by the reciprocal of the fraction. So we have -30 minus 16 minus 1, which simplifies to -47. For a review of how to manipulate fractions, see our Fractions series. Substitute a equals 6 into this expression and simplify. Replacing a with 6, we get 90 minus 6 over 7, plus 6 plus 57 over 9, all squared. Simplifying the expression inside the parentheses, we have 84 over 7, plus 63 over 9, all squared, which reduces to 12 plus 7 quantity squared, or 19 squared, which equals 361. Find the value of this expression if x equals 3, y equals 2, w equals 1, and z equals -1. Substituting the values, we get, applying the rules of the order of operations, simplifying from the innermost grouping symbols first, we have, which simplifies to -7. Find the value of -x cubed plus 3x minus 3 when x equals -1/2. When a number is raised to an even power, the result is always positive. Substituting -1/2 into the expression, we have, when a negative number is raised to an odd power, the result is always negative. The LCD is 8, so we can write all of the terms as fractions with denominator 8. So we have 1/8 minus 3 over 2 times 4 over 4 minus 3 times 8 over 8, which reduces to -35 over 8. In algebra and more advanced math courses, variables can be differentiated from each other by using the same letter or symbol but a different numerical index called a subscript. So b sub 1 and b sub 2 can represent two different values. Evaluate b sub 1 plus b sub 2 times h if b sub 1 equals 3, b sub 2 equals 5, and h equals 12. Replacing the variables in the expression by their numerical values, we have 3 plus 5 inside of the parentheses and a factor of 12 outside. Simplifying the inside first, we get 8 times 12, which is equal to 96. Given this expression, replace x with 2, then simplify. Replacing x, we can reduce the numerical expression to 7 over 20 plus 3 over 100, quantity squared. The LCD is 100, so the sum of the fractions reduces to 38 over 100 squared, which we can reduce to 19 squared over 50 squared, and then 361 over 2,500 after squaring. As a final example, let's evaluate this expression with an absolute value. If w equals 4 and z equals negative 2. Substituting for w and z, we get the square root of 4 is 2, and as mentioned earlier, the negative number 2 is raised to an odd power, 3, so its result is negative 8. Simplifying, we get the negative of the absolute value of 10 over negative 2, and the negative of the absolute value of negative 5. The final result is negative 5, applying the rules of absolute value.